We'll find the domain of these two functions. We have a radical expression. So remember that if we have a radical sign, we need to make sure that the inside is greater than or equal to 0. Because if we have a negative inside the radical sign, that would be imaginary. So we need to make sure that the inside, and in this case that is x minus 3, is positive or it's equal to 0, which means it's greater than or equal to 0. When we solve this inequality by adding 3 on both sides, we get x greater than or equal to 3. So the domain of this function is all real numbers greater than or equal to 3. So anywhere from 3 to infinity. And that is including 3. Now suppose we had f of x equals 1 over radical x minus 3. Here we would think exactly the same way, except for one little thing. First of all, we need to make sure that x minus 3 is greater than or equal to 0, but then if x minus 3 were to be equal to 0, then we would have a 1 over 0 which is undefined. So therefore, we consider x minus 3 greater than 0. So for the radical expression to be defined, x minus 3 has to be greater than or equal to 0. But the problem is that if x minus 3 is equal to 0, since the expression is in the denominator, we would get a 1 over 0 which is undefined. So in this case, we'd have all real numbers greater than, so x is greater than 3 when we add 3 on both sides. So that is anywhere from 3 to infinity, not including 3. So if that's a 3, put a hole there, and then everything to the right of 3 is included. Now let's look at the next problem, which is radical x minus 2 times x plus 4. So what's inside the radical sign? So x minus 2 times x plus 4 must be greater than or equal to 0. So let's think about when it would be greater than or equal to 0. So greater than 0 would mean positive. It would be positive if each is a positive or equal to 0. That's case 1. The inside would be positive or 0 if each of the factors is greater than or equal to 0. So the first factor greater than or equal to 0, and the second factor is greater than or equal to 0. So that is x greater than or equal to 2 and x plus 4 is greater than or equal to, greater than or equal to negative 4. So x has to be greater than or equal to 2. So if that's a 0, that's a 1, 2. And x is greater than or equal to negative 4. So everything to the right here. Both have to be true. So if a number is greater than or equal to 2, we can be sure that the number x is greater than or equal to negative 4. So these two inequalities can be replaced by just one. Since both have to be true, x would have to be greater than or equal to 2. If x is greater than or equal to 2, then automatically x is greater than or equal to negative 4. That's the solution for both the factors being greater than or equal to 0. So we are looking at the inside of the radical expression, and we are trying to figure out when the inside would be greater than or equal to 0. So positive times positive is positive. We also have two negatives, a product of two negative quantities or numbers would be also greater than 0. So another case is x minus 2 is less than or equal to 0. So that's negative or 0. And x plus 4 is less than or equal to 0. Both have to be true for the inside to be either positive or 0. So when we solve this by adding 2 on both sides, we get x less than or equal to 2. And by subtracting 4 on both sides, we get x less than or equal to negative 4. So x has to be less than or equal to 2 and less than or equal to negative 4. So if a number x is less than or equal to negative 4, it's to the left of 4, in which case it will be less than or equal to 2. So we can replace the two inequalities with x less than or equal to negative 4. So in either one of these cases, the inside function, which is x minus 2 times x plus 4, so what's inside will be greater than or equal to 0 when x is greater than or equal to 2, or when x is less than or equal to negative 4. So 2 or greater, or negative 4 and less. So this would be negative infinity to negative 4 union 2 to infinity.